Question number 7. The curve C1 has polar equation r is equal to a into cos of theta plus sine of theta for -1/4 pi to 3/4 pi, where a is a positive constant. Find a Cartesian equation for C1 and show that it represents a circle stating its radius and the Cartesian coordinates of its center. Now, by definition from polar coordinates, we know that r square is equal to x to the square plus y to the square, and also cos of theta is equal to x over r, and sine of theta is equal to y over r. So if we were to substitute these into this equation over here, this is what we'll get. And so r is equal to a into x over r plus y over r. Okay, as can be seen, that's a common denominator over here. So we have a into x plus y, all of that over r, and so r square is equal to a into x plus y. And as we've seen before, this is x squared plus y squared, for r square is equal to a into x plus y, and so we have x squared minus ax plus y squared minus ay if we were to rearrange all of that. So now we're going to complete the squares, and in doing so, this is what we get. Now we're going to rearrange it, and hence we have our circle with center a over 2, and radius is a over root of 2, because r square is equal to a square over here over 2, and if we were to send the square on the other side, this becomes then a over root of 2. Moving on to the second part of the question. Here, we've got to sketch the curve, C1, and state its greatest distance. Remember, this is for -pi over 4 being less or equal to theta, less or equal to 3/4 pi over 4. So we're going to compute the radial axis for those values of theta. And in doing so, this is what we get. Now we're going to try to sketch the circle. So what we're going to do, we're going to draw the radial axis. So this is our radial axis, Now for -pi/4, we're going to start here at 0. This is the angle minus pi/4, and starts here at 0. And for this angle here, which is actually 0, so we have 0 is equal to then 1. So we're going to say, let's say 1 is somewhere here, and then we have pi/4, which is this is pi/4, and on this axis here we have something like a root of 2 over here. So that's the distance here from the pole, and then we also got pi over 2, which is then 1 again, so 1 somewhere over here. And then for 3pi/4, for all that angle over here, we're going to go back to 0. So we're going to trace our circle, which is going to go like something like this here. And here we are. Now to state the greatest distance from its pole over here, so we know that the circle is going like this, like this here. So the greatest distance is that from a point on the curve here. So that's going to be twice the radius of the circle. So that's twice root of 2a over 2. So the root of, a second, let me just check the radius. We just got that at the beginning here. So yes, our radius is a over root of 2. That's root of 2 over 2. So root of 2 over 2, so the 2 and 2 can go. I have a root of 2, which is the greatest distance. So here we are. Now we're going to move on to the third part of the question. Now to verify that the 1.25 is less than 5 is less than 1.26, because these two curves are intersecting each other, that is C1 is equal to C2, they're intersecting at the pole as well as at the point with polar coordinates this. So now what we're going to do, we're going to equate each of these equations. So we have a theta, I'm going to call it phi now. So a phi is equal to the other equation, which is a into cos of phi plus sine of phi. So now we're going to build an equation here. So I'm going to say a into cos of phi, okay, minus plus sine of phi, and then minus this one here, minus a phi, and all of that should be equal to f of phi. And now what we're going to do is we're just going to try and substitute the values in there. But before we do that, we can also cross this out and cross that out so that we don't have the a over here, or maybe we can say a could be equal to 1 as well. So there we go now, because this is our equation. So we're going to try and substitute those two values here and see what happens. After substituting the values, this is what we get. There's a value of 0.143 over here, and here it's a negative. So we have a change of sign, which in fact goes to show that there is a value between 1.25 and 1.26 where the two curves intersect. So that is the change of sign that indicates. Now moving on to the fourth part of the question. Part D of the question here now. Show that the area of the small region enclosed by C1 and C2 is equal to all of that expression over here, and then deduce in terms of A and phi the area of the larger region enclosed by C1. Okay, so for part D of the question now, we need to show that the area of the smaller region enclosed by C1 and C2 is equal to all of that here as said before, and deduced in terms of A and phi the area of the larger region enclosed by C1 and C2. So we're going to use the formula integral of half r squared d theta. And so we have for C1, this is our equation, and for C2, this is our equation. So we're going to add them up to get. The reason we add this up is because the region enclosed here is given in the diagram, as you can see over here. This area here is a combination of both of them. So we add them up, and so that's going to become then half into r squared for C1, and then integrate with that r squared for C2. So we're going to write all the equation here and some of the steps, and this is what we get. Now we're going to try to integrate both of them, but before we do that, so we have here cos theta plus sin theta needs to be expanded. And if we were to expand this, we're going to get from quadratic expansion, and this is what we get. Now let's try and integrate this. So we have half a squared, so that's going to become theta to the cube divided by 3. And applying the limits here, we have 0 going to all of that, plus half, and there's an a here, a to the square. For the upper limit and lower limit here, we have phi to the cube over 3 minus 0 plus half a squared over here. The upper limit is going to be 3/4, because theta is 3/4 pi, and then plus the sine square of 3/4 pi, which is then half. And so that's the upper limit minus the lower limit here. I've got this phi is going to come here. And so we have also sine square, so that's going to plus sine square phi. Sine squared phi, yeah, that's cool. So now we're going to try and simplify all of that. So we have half a square and half a square can be actually factored out. So now we're going to factor this half a square, and then inside I've got phi to the cube over 3. Okay, plus 3/4 pi, okay, minus the phi over here, okay, and so what we have is, we have the upper limit, that should have been the minus the lower limit, so that is phi minus sine square phi. Now, we also have the plus half over here, which then becomes plus half minus sine square phi. So over here we've got to do something. So 1 minus 2 times sine square is 1 minus 2 sine square phi over 2. Now that in itself is actually half cos of 2 phi. So we can just substitute this for half cos of 2 phi, and this is what we get. So actually, because there's a plus here, so this is plus and this is minus, so this becomes plus, and that's what we end up with. Now let us see. So rearranging this, I have 3/4 pi, okay, then plus 1/3. This is 1/3 phi to the cube minus the phi over here plus the half cos of 2 phi. So now that has been shown, and here we are for part D of the question. So the area of the larger region is actually enclosed by C1 and C2, where we had this over here. So C1 plus C2, area bounded will be the larger area in terms of phi and pi alpha as well. So here we are, in terms of A and phi rather. Take care.